In this tutorial, we're looking at 2023 Paper 1 Question 7, and it's all about calculus. In the first part of the question, we're told that Fiona drives past the point A on a motorway, and we're given a formula, v of t, that describes her velocity t minutes after she passes the point A. We're asked to work out her velocity when she passes the point A. Well, if we've been told that this formula is t minutes after she's passed the point A, obviously when she's at the point A, 0 minutes have passed since she was at the point A. So that means they're telling you to sub in t equals 0. We want to figure out what was her initial speed. The moment she passed the point A, what was her initial speed? So simply, everywhere there's a t, you sub in a 0. Everything cancels out except for the last term, so our answer is simply 109 kilometers per hour. In part B, we're asked to work out Fiona's acceleration after 5 seconds. So we've covered this content in differentiation 18. If you're not sure about the relationship between distance, speed and acceleration, go back and look at differentiation 18. The relationship between speed and acceleration is that acceleration is the rate of change of speed. In other words, in the question we've been given speed, so if we simply differentiate, that will give us the acceleration. The derivative, if we've 2/3 t cubed, we bring the power in front, and if you bring a 3 in front, the 3 and the 3 on the bottom of the fraction here will cancel, and we're simply left with 2. And t cubed becomes t squared. The derivative of minus 6t squared is minus 12t to the power of 1, and the derivative of 13t is 13. So this is a formula for Fiona's acceleration. We're asked to work out the acceleration after 5 minutes. That means everywhere there's a t, you sub in a 5. And when you work it out, your answer ends up as 3. It works out simple enough at the end. Now, we were told in the question that the speed is in kilometers per hour, but that t is in minutes. So that means the units we're using here are kilometers per hour per minute. The speed is kilometers per hour, but now we have to account for the fact that it's kilometers per hour per minute. So that's your final answer here. In part C, we're asked to work out Fiona's maximums. In part C, we're asked to work out at what time t does Fiona reach her maximum speed within 4 minutes after reaching the point A. So we're looking for a maximum here, so this is a turning point question. If you want to study questions similar to this, go back to differentiation 15, where we studied all about maximum points and minimum points. In order to identify a turning point, you get the first derivative and you let it equal to 0. So that's what I've done here. We have v of t. If you differentiate, you get 2t squared minus 12t plus 13. And to identify a turning point, you simply let this equal to 0. Now, we know we need to leave our answer to 2 decimal places, so we're not going to be able to factorize this off the top of our heads. We're now going to use the minus b formula to work out the turning points, the values of t that correspond to the turning points of the speed. Okay, so in order to solve this quadratic, we're just going to use our minus b formula. Our a in this case is 2, our b is minus 12, and our c is 13. If you sub in your minus b formula, it looks like this. And if you use the plus, your answer is t equals 4.58. If you use the minus, your answer is t equals 1.42. We're looking for the maximum point that is within the first 4 minutes. So this must be our maximum point. The maximum point or the maximum speed is reached after 1.42 minutes. In part D, we're asked to work out Fiona's average speed over the 5 minutes, correct to 2 decimal places. They've told you to use integration here. Remember that we covered the average value formula in integration 11. So if you're rusty on this, go back over the content in that tutorial. Your formula for average value is, if you're using the limits b and a, you simply multiply by a fraction in front of your integral. It's 1 over b minus a. And then you simply integrate whatever your function is, in this case v of t. So we're asked to do it over the first 5 minutes, which means our limits are going to be 5 and 0. We're simply going to integrate, v of t, and the limits are 5 and 0. The only difference, the only thing you add in for the average value formula is this fraction. It becomes 1 over 5 minus 0. And obviously that works out as 1/5. When you integrate 2/3 t cubed, it becomes 2/3 t to the power of 4 divided by 4. And minus 6t squared becomes minus 6t cubed over 3. 13t becomes 13t squared over 2. And 109 becomes 109t. What I did then in my calculator, I take 2/3 and I divide it by 4. 2/3 divided by 4 is 1/6. So this term is just 1/6 t to the power of 4. And 6 divided by 3 is 2. I haven't tidied up the other two yet. So all we have to do now is we're going to sub in our limits and we're going to get our final answer. Okay, in part E, we're told that the first derivative at 1 is greater than 0. And the second derivative at 1 is less than 0. And we're given these four graphs and we're asked which one represents v of t. So let's just describe what's going on here. So the point I've marked in here, the point that's marked in each of them is the point where t equals 1. The first one here has a negative slope, and then when it hits 1, the slope rapidly decreases. It's much sharper and it rapidly decreases. For B here, the slope is rapidly decreasing, and then after the point that's marked, it starts to level off a little bit. For C, it's rapidly decreasing, and then after the point, it levels off a little bit, but it's still going down. For D, it has a positive slope, but it's relatively level until it gets to the point, and then it rapidly increases. The first derivative represents the slope of the curve. So the first derivative at 1 is greater than 0. In other words, it has a positive slope, which means it's definitely not A and it's definitely not C. B has a positive slope and D has a positive slope. Now we have to figure out which is which. And to figure out whether it's B or D, we have to look at this. The second derivative at 1 is less than 0. The second derivative refers to the rate of change of the slope. So if the second derivative is less than 0, it's negative. That means that the rate at which the slope is changing is negative. And that means that B is the answer to this question, because it has a positive slope, and when it reaches the point where t equals 1, the slope is still positive, but it's not as positive as it was. It's not as steep as it was, so it's beginning to level off. In other words, the rate at which the slope itself is changing is negative at that point. It starts to level off. Whereas this one is the opposite. As we approach t equals 1, the slope, it's a positive slope, yes, but it's relatively gradually positive. And then after the point t equals 1, the rate at which the slope is increasing gets much bigger and it gets much steeper. So the answer is B, and now we're just going to put that into a sentence. So what you need to say to get the full marks there, your answer is B. And to explain each one, the first derivative being greater than 0, this means the slope is positive at t equals 1. Obviously this graph has a positive slope, so that makes sense. And the second derivative is less than 0, and the second derivative refers to the rate of change of the slope. The rate of change of the slope is negative at t equals 1. In other words, it has a positive slope, which is really strong positive slope, but then the rate at which the slope is changing actually becomes negative. It's still a positive slope, but it's not as steep as it was. Okay, in part F of this question, we're told that the point A and the point B are 10 kilometers from each other. We're told that the speed limit on this stretch of road is 100 kilometers per hour. We're asked to work out what is the minimum amount of time you could spend driving from A to B without going faster than 100 kilometers per hour. Well, if you don't want to go faster than 100 kilometers per hour, to find the minimum time, we want you to go exactly 100 kilometers per hour. We want you to be going bang on the speed limit. So it simply means the distance is 10 kilometers, the speed is 100 kilometers per hour, and you should remember that time is calculated as distance divided by speed. So in this case, 10 kilometers divided by 100 kilometers per hour, that works out as 0.1 hours, or in other words, 1/10 of an hour, which is 6 minutes. So that's your answer for this part of the question. Part G is directly related to part F. We're told we know the distance from A to B is 100 kilometers per hour, and it should take you 6 minutes. Unless you're going to be caught speeding, unless it takes you 6 minutes to get from A to B. We're told that Rohan passes the point A at 120 kilometers per hour. And we're told that he maintains that speed for 2 minutes. So since the speed is in kilometers per hour, to turn minutes into hours, you divide by 60. So 2 minutes in hours is 2/60. So the first thing I want to do is figure out what distance has he covered in the first 2 minutes. Distance is speed multiplied by time. In other words, to work out the distance he's traveled in the first 2 minutes, it's 120 by 2 over 60, and that works out as 4 kilometers. So he's on this journey and he's 2 minutes in, but he's already traveled 4 kilometers. So this is 4 kilometers and it only took 2 minutes. So I'm not really concerned anymore about the start of this journey. I'm only concerned now about the second half or the latter part of this journey. I know that he has another 6 kilometers to go. And we know that his average speed throughout the journey is 100 kilometers per hour. In other words, we know that it takes him 6 minutes to get from A to B. So he's already used up 2 minutes. That means there are 4 minutes remaining. And I need to figure out what is his rate of deceleration. If he's going to travel 6 kilometers in 4 minutes, exactly 6 kilometers in exactly 4 minutes, and he's starting off, like I'm going to wipe this out because I don't care about the start. I know that initially he reaches this point, he's traveling 120 kilometers per hour. So in order to figure out his deceleration, the easiest thing to do, he's decelerating at a constant rate. So I want to figure out, he starts off going 120 kilometers per hour. If I can figure out what speed he ends up with, like does he end up at 40 kilometers per hour, or does he end up at 50 kilometers per hour, or whatever it is. If I can work out the speed he's traveling when he reaches the point B, I'll be able to figure out the deceleration. I'll be able to figure out the rate at which he was slowing down. So deceleration is the rate at which his speed is going down. So what I should work out now is, what is Rohan's average speed for this segment of the journey? Well, I know his distance. The distance he's going to cover is 6 kilometers. And the time it's going to take him is 4 minutes. But it makes more sense, since we're obviously trying to find the speed. I don't want the speed in kilometers per minute. I want the speed in kilometers per hour. So I'll divide the 4 minutes by 60 to turn it into hours. And that will allow me to get the speed. So if I take my distance, which is 6, and I divide it by the time, which is 4 over 60, I'll plug that into my calculator, and I work out that the average speed in this part of the journey has to be 90 kilometers per hour. So over just the little segment here, his average speed is 90 kilometers per hour. And I know that his initial speed, when he rocks up to this point, he's 6 kilometers away from B, he's speeding, he's going too fast. I know that his speed initially is 120 kilometers per hour. But I know his average speed over the whole thing has to be 90 kilometers per hour. So I can use this information now to figure out what is his average speed at the end. I want you to think about other ways of figuring out the average speed. I know he's decelerating at a constant rate. I know his initial speed is 120 kilometers per hour. And let's refer to his final speed as V. The speed he's going at the end of this journey, let's just refer to it as V. So if I want, another way of working out the average speed is, you'd get the initial speed, you'd get the final speed, and you'd divide it by 2. The initial speed plus the final speed divided by 2 would give me the average speed. And the reason that is true is because he's decelerating at a constant rate. He's not like decelerating a load and then continue just cruising and then decelerating again. He has his foot on the pedal at the same rate the whole way along. So the initial speed plus the final speed divided by 2 would give me the average speed. We already worked out the average speed in this journey, which can also be calculated as distance divided by time. Well, it's simply 90. In other words, I'm coming up with a formula here that's going to allow me to work out his final speed, the speed at which he crosses the point B. Obviously, I just multiply both sides by 2 here to get rid of the fraction. I could say 120 plus V is equal to 180. And then I would subtract 120 from both sides, and I'd work out that V is 180 minus 120. In other words, it's 60 kilometers per hour. Now I'm basically done. I can write down my answer. So I want you to just think about this now. I know that 4 minutes before he reaches the point B, he's traveling 120 kilometers per hour. And 4 minutes later, he's traveling 60 kilometers per hour. And for that entire 4 minute period, he's decelerating constantly. So now you could just think about, well, how much slower is he going? How many kilometers per hour slower is he going? his speed has decreased from 120 kilometers per hour to 60 kilometers per hour. So the decrease in speed is 60 kilometers per hour. And that has occurred over 4 minutes. So if I want to figure out how many kilometers per hour does his speed decrease by every minute, I just divide this by 4. His speed over the course of 4 minutes, his speed has decreased by 60 kilometers per hour. Or in other words, 60 divided by 4, that means that every minute his speed has decreased by 15 kilometers per hour. So the deceleration is 15 kilometers per hour per minute. In other words, every minute in this part of the journey, his speed was decreasing by 15 kilometers per hour.